and one question alone today, well, not one question alone, this question can have many different questions. So let's begin with this question. Into how many squares can we cut a square? Into how many squares can we cut a square? That's our opening question. And that question will keep us busy for the next 45 minutes. Yes?
I think how many squares is, it can be either a power, it has to be a power of 4.
It has to be a power of 4?
Yeah, like 4, 1 is 4 to the power of 0, and then 4 to the power of 1 is how many squares you can cut it into. Because if you cut it in one time, it's only two rectangles. If you cut it twice, it's 4 squares.
And then you cut every single one that's
16 squares. Then.
So you would say that if it is a power of 4, and if it is not a power of 4?
Then I don't know. Like
That could be.
it could, but for the first one, if it's not a power, if it's not 4, then it couldn't be it couldn't be a square. If for like the first.
Do we understand? Let's see. Do we understand the question?
Yes.
Do we? Okay. So we wanna. Can anybody explain the question? Just explain the question. Yes, please.
So we have one square, and then we do multiple cuts to it, and so we find out the number of ways we can get the number of squares that can be resulting of the number of cuts.
We do a number of cuts, and do we have any conditions, any restrictions on those pieces that we cut? So we cut. So we want to cut them into squares, and only into squares. What does that
If you
mean?
make one cut, then it'll be a rectangle.
Yeah, but so what?
That means
So into how many squares can I cut a square? We're all understanding the question.
Is there?
Yes.
Do you have to make one cut at a time, or can you make multiple cuts?
Well,
Yeah.
you're gonna make cuts. When you make these cuts, it's not so important now. It might be, but right now we're just trying to understand the question. So we're trying to, okay, so into how many squares can I cut a square? So, yes.
If you take the square and cut once, that would become a rectangle. Is that what? So we're allowed to cut as many times as we want. The end result should be a square.
We're allowed to cut as many times as we want as long as every single piece that results is a square. That's it. So as long as every single piece that results when we do these cuts, so we don't want any extra weird pieces hanging around. No. We cut our square and we want to end up with only squares.
Yeah, then it has to be a power of 4.
It has to be a power of 4.
Yeah.
So, and if it is not a power of 4, it won't work.
Yeah,
No,
because
it
there's
won't.
not gonna because one of them might be a square. One of them might be a square, but like the others could be other weird shapes.
It depends on how many side squares are there, because like for example, let's say we do a plus shaped cut there, that results in 5 squares, which is not a power of 4. Because 1, 2, 3, 4, and then the big square at the end.
Oh, but we're cutting, remember?
We're cutting.
We're cutting.
It's
We're
in-
cutting.
You can
Cutting.
split them apart.
Oh, okay.
We're not just counting squares, we're counting squares, but we're cutting. And we want to cut our pieces, yes.
Does it matter what direction the cut is in?
Does it matter what direction the cut is in? What do you mean by that?
Straight line.
So
and
does it
can't
have to be
diagonal.
horizontal?
Has to be horizontal or vertical.
Well, the only restriction is that we want to end up with squares.
So what if
Yes,
you do a
so
diagonal line, you end up
If
with
we do a
triangle.
diagonal line, it would be.
So maybe we don't want to do that,
Yeah.
right?
Horizontal or vertical.
Yeah.
Yeah, it has to
Yeah,
Yes.
so our cuts, so you see, so from the question, now you're seeing that there are some restrictions that arise naturally. They say, oh yeah, I don't want to cut it diagonally because, yeah, I might be able to cut a square diagonally, but I'm going to end up with some pieces that are not. So you can see, so this is good, this is good. So we are seeing some limitations in the problem, some things that we don't want to do. And it's opening up new ideas. So 4. Only powers of 4. So just 4. What would powers of 4 be then?
4 to the power of 1 is 4. 4 to the power of 2 is
Oh, wait.
16.
No.
So only
No, wait,
those.
listen. Oh, I
No,
just
no.
realized. Okay,
It
you
has-
can cut into
it
4,
has-
but then you can only cut 1. And then you can leave the rest. and then you can keep cutting.
So, okay.
Yeah, so it has to be a multiple of 4, not a power
Yeah,
of 4.
multiple of 4.
A multiple of 4.
So it's,
So if it's not a multiple of 4, it doesn't work. So that's your conjecture?
yes.
That if it's
Yeah.
not a multiple of 4, it doesn't
No,
work?
no,
It
depends.
I mean,
Because
we're
it doesn't
fast,
matter
we're-
about number of 4. Because, for
It has to
example,
be
let's
a
say,
perfect square.
let's say, no, it doesn't have to be a
Perfect.
perfect square. You can create 7 squares. For example, let's say you cut a square, then you cut it into 4 pieces.
Can we see that? He wants to do 7. Let's see how you do 7.
Okay.
Let's go to the board, let's see how you do it. He says he can do 7.
We
Look,
can't
we have
count.
markers here, we can use color.
Oh.
Got it.
So we have a square. We cut it, okay? So that means there's 3 pieces. They're gone.
Wait. Okay, okay.
We have our 3
Just
squares.
cutting them, and then, yeah.
Then we have our 4 squares. So it would be 1.
That would be 7 squares, yeah.
Yeah, so 1, 2, 3, 4, 7.
Okay, so he cut it into 7. Yeah, I mean, if we return these pieces back, if we return them to our squares, so he says we started out with this square, and how can you guarantee that this was a square?
Because we cut into equal sides earlier.
No, but how do you know when you chose your square, you chose it in a particular way? What did you do to it? You chose a
I
square.
cut it such that these 2 sides are equal.
Okay. Yeah. So he had a square and he split it into 4 squares, and then he took one of the squares and split it into 4. So he ended up with 3 and
You don't have to.
these 4. Okay. So we're good. We're good. So my question is, yes.
So the squares can also be microscopic, right? Because we're going to end up with this.
The squares could be tiny. Yeah, we don't have a.
It
At
could be a
this
larger
rate-
square in the
Yeah.
But that brings up another issue that we might want to address. We will address it. We will address those tiny squares, but right now, all we care about is, can we cut it into how many squares can we cut
I
it?
don't think you
So-
know anything about this.
Yes, I have
Well, can we do 11? Can we do 11?
Yeah, we can do
No,
11.
no.
No.
All right, okay, take 30 seconds. Take 30 seconds or 60 seconds, take a minute. See if we can do 11. Let's see if we can cut it into 11 squares. Let's see if we can cut it into 11. Let me see if we can, show me 11. Can we cut a square into 11 squares?
So
Can we
there's
cut it into 11 squares? Let's see what we have
there's
here.
4 squares right here, then 3 squares over here. And then there's 1, 2, 3 more.
squares.
Yeah.
But that makes how many?
That's 10.
Oh, that's 10. Okay, not bad. I mean, close to 11. Not bad.
No, I didn't get 11, but I have a concept. I don't think so we can get 11 because whenever we make a new plus cut, we add 3 squares. For example, when we make our first plus cut, we
That's
had
my
4
son.
squares. Then if we make our second plus cut, we have 7 squares.
So it adds
If we make
3.
our third plus cut, we have 13 squares. 10 squares, then we go 13, 16, and so on.
Oh, there is there's a powerful idea here. I like this idea.
But then you don't use a plus cut.
Then you just don't use a what?
Yeah, plus cut.
Plus cut, okay.
Yeah, because I found a way to make this, and then you get 4 squares right here, and then 4 squares right here, and then 3 squares right here.
Okay.
11 squares.
So you end up with, let's see.
11 squares? Like 4 squares right here.
And how do you know this is a square? How do you know that's a square?
Because,
How can you guarantee this is a square? And it's not a rectangle in disguise.
no,
another
because
rectangle?
the starting shape was a square, and then when I made this thing, I made these the same length, so you just divide this length by 4 to get the length of each square.
So you're starting out with a 4x4 square, is what you're telling me.
Yeah, sure. And then, it doesn't matter what this length is, this one will just be the length of this whole side by 4, and then like this one will be the same as this one, this one, this one.
Okay,
And then
okay.
as well as this one, this one, this one, this
Uh-huh.
one, will also be the same as these.
Yes, and
Yeah,
then?
and then these will just be these 3, the
Yes.
length of these 3. So then that would just be this side by
Would you like to draw it?
4 times 3.
Would you like to draw it on the board? Let's see. Yeah, we have an idea, and that's nice. And we want to go back to let's see what we have. He's making a square. Just a quick refresher. I just want to make sure that everybody is on the same page.
16 squares.
What?
That's 12. That won't
let's see, let's see.
No, I see. Is it 16? Is that a 4x4 square?
Oh, but
Oh, everything used.
Wait, well, what would the dimensions, wait a minute.
What would the dimensions be?
Yeah,
You would
yeah.
be dividing it by 3 on that side. So
yeah.
those are unequal.
Yes, we have some people have some reservations here. So let's see.
So this would be,
I don't think that looks exactly like what you drew on paper was slightly different than this. Do you see? Do you see?
yeah.
Oh,
Look at the paper.
okay, okay.
Oh, yeah, right here. Right there. But then this would be 1/4. These sides would be 1/4 of the whole side. And then as well as these sides, 1/4, 1/4, 1/4, 1/4. And then this one would just be,
That would be 3/4 divided by 3.
It might be
So it
easy.
would be unequal.
It
Oh,
might.
wait, actually, no, those are squares, yeah.
yeah, those are squares.
Using that same, what he's doing, can anybody use that same approach and simplify the language that we're using? How can we he's saying 1/4, 1/4, and then 3/4. Can we simplify that language so that maybe
Imagine this is like an 8x8 square. And
an 8 by 8?
like
Yeah.
8, yeah.
Okay.
8 units by 8 units.
8 by 8 is good.
Okay, 2, 2, 2, 2 at the bottom, and then 2, 2, 2, 2 for the.
Okay, what 8 by 8 would be, do you think it could be? Does
And then
it seem like the most natural way to look at it? I mean, it could be.
2, 2 cubed.
2, 2, 2x, we have a,
Oh, I have another for
you want to share something? Yes, let's share it. Let's finish with this one, and we'll call on you
The
very soon.
4 larger squares are 3 by 3s, and then the rest are 2 by 2s.
So, if they are 2 by 2s, can we think of them as 1 by 1s? Just a suggestion. Can we look at it as 1 by 1s?
Yeah.
And then these two would be what?
Those would be 1, yeah.
1.5 by 1.
1.5.
Yeah, but it's easier to just look at them as whole numbers by whole numbers.
Yes,
So
so,
it'll just be easier to operate with.
like what, like what? But these are not whole numbers.
No, like the dimensions. Is
Also,
Yeah.
the area is also good.
The dimension of the square, you mean? Okay, so, am I allowed to start, say, with a 4 by 4?
Yeah.
Say, if I start, let me see, it looks similar to this, but my 4 by 4, this looks like I'm taking, these are 1 by 1s then? Would they be 1 by 1?
Yeah.
If I start with I don't want to ruin your approach, I'm trying to
So it'd
see.
be 1 by 1s.
Okay, so these would be 1 by 1s.
Yeah.
Okay, so I don't want to, and then I would have 3 here, right?
Yes.
Because we started out with the, and
Yeah,
then,
and then the bigger ones would be 1/2 by 1/2.
so now I have 1, 2,
One
3,
and a half.
4, 5, 6, 7, and you want to
yeah,
cut,
sorry, 1.5 by 1.
so this big one,
Yeah.
we're cutting into,
Yeah.
this is a square. This big one is what? The big one is
Is
3
it
by,
3 by 3?
Yeah.
the big one, this
Big one.
big
No,
big
that
one.
big one is
Not
3
the
by-
big one.
Yeah,
The
big
middle one.
is, yeah.
The
3 by
medium
3.
size.
Yeah.
Yeah, and then when you cut that, that's gonna be 1/2 by 1/2, and there'll be 4 squares.
And we agree that there are
They're squares,
They're
yeah.
squares.
11 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11.
And if we agree this is a 4 by 4, you can see that the area adds up to.
Yeah, yes, exactly. So the area, so it's 1/2. 1/2 is 3 and 1/4, so we have a 4 by 4. Everything in there is a square. Excellent.
Like you could also.
But, wait, I have an idea back here. Yes.
So I was thinking that maybe for each one, because it says how many squares,
Yeah.
it's like it's not for each like solid one, right? So for this, it'd be like that. And for you can break down each one, but let's just take one. You could take this and to do that to this one.
Yes.
You get
Yes.
that one. You get that one.
But we're cutting. Remember that we're cutting.
Oh,
Remember that we're cutting. Let's not double count or triple. Remember that we're cutting. In fact, just to emphasize this concept of cutting, I'm gonna give you guys grid paper. It might help us visualize the cuts. It might help you visualize the cuts. So, let's see, this might help us with, we don't need graph paper, and I noticed that I made the squares a little bit bigger. I think it'll, and I also have scissors if you want to actually cut. Okay, so I do have some pairs of scissors.
This is square.
If you actually want to, oh, well, is it a square?
I think it's like 19.
Yeah, so it's not a square, but it's okay. You just have to pick a square. You just have to
Wait.
pick a square.
You don't have to draw the full lines over the thing. So you could just do.
Okay, let me, look, guys, if you want, it might be easier when you start cutting to use color pencil. So if you want, I have a few.
Okay.
It just makes things easier. Let's.
Yeah. Okay. So if you have these, if you have a 3 by 3 square,
Yeah.
you can divide it into 9 squares, right?
Yes.
Yeah. Three of the squares could be left blank without any cuts.
Yes.
Then these squares could be cut like this,
Yes.
and then you could stop, it right there, and don't make a line right here. You can make another one of those squares. Take off that and these.
So how many do we? What are we looking for? How many are we trying to?
So this has 4.
Yeah.
4.
Yes.
You can make this into 1 or 4. I made into 1, another 1. So that, and then 4 squares are right here. So that's another 4. So 4, 4, 4, 4, 4.
What are you trying to look for? So what were you looking for? What number were you looking for?
We can make any number. We can make any number with this. With
Any number.
Any number.
Oh. So can you make 6 with this technique?
Yeah, you can. Yeah, you can.
Okay. So let's see.
It has to be within. It has to be greater than 9.
Okay. So what do we have? Okay.
But then any number.
So why don't we?
Nine.
Okay. So we've come up with different numbers. So already, right? Like what do we have so far? What did we come up with? We came up with 11. We came up with, what was this? 7. So we have 7. We have 11. Are there some easy ones?
24.
Well,
I won't say an easy one, but like, there's no way we can, I object to statement saying we can do all numbers because, for example,
Yeah.
what about 2?
Yeah, it has to be greater than 9.
No, not necessarily. We just make one cut and we have 4 squares.
Really?
Yeah, it's like what we did in the beginning. Remember?
Oh yeah.
so okay, it's good. We're making conjectures.
Wait, 1 cut, 4 squares, where did that come from?
Yeah.
That's in the beginning. The one we did, our plus cut.
Just they're looking at a 2 by 2.
Oh,
If you
but,
think about
but
it.
that's 2 cuts then.
Yeah. No. But it's what they mean is you have 4 squares. You have 1.
Yeah, that could work.
One plus cut.
Yeah, it's 2 cuts. But at this point, at least, we're not counting the number of cuts. We could. That's a different problem, and we could count the number of cuts. But right now, we're just saying cut and count the number of squares. But now, what do you think is the next step? We were able to do 7. We were able to do 11. Can we do?
Next
What are there any easy ones? Any easy that you say? Yeah, of course we can do this one.
16
16.
square.
16. Yeah, we can do 16, and then we can do.
8?
We can do 8. You think 8 is simple?
No, it's 1, 2, 3, 4, 5, 6, 7, and then this large square.
Oh, but see that I like that one. So Varun did 8. Varun did 8.
I could do
So why don't we start? What do you think should be the next step? We're coming up with some numbers, 8, and we're gonna show you Varun's 8 now. We found 7. We found 11. What should we be trying to do?
We should be trying to do some really low and really high decimal numbers. Decimal.
like this.
That's
We
what.
can do decimals. No, not decimal number. Prime numbers.
Prime numbers.
Yes.
What we already tried.
But we already tried
seven.
7. We already did
And
that.
11.
We can try 13. Yeah, that would also work.
Yeah.
So-
what prime numbers happen?
It's basically
about
Why don't we keep track of what we have found? It's usually a good way to keep track of what we found.
So what would I think what we can do is we can try to find the numbers which it would not occur that are greater than at least 4, for example.
Perhaps. So yeah, okay, I like that. So why don't we keep track of what we have? Do we want to do that? Do you think it's
Yes.
good to do that? I mean, because we have we're saying, oh, 8, 7, see, 11. But if we want to be able to find some kind of pattern, it would help us if we keep track of what we're doing, right? I mean, do you think it's a good idea?
Yes.
Want to do that?
Yes.
Okay, so let's see, because I'm hearing so many ideas and I want to, my brain can't keep up with so many ideas. I just want to see what we have found. Yes.
So I have a statement that every number that is one more than a multiple of 3 can be solved by squares. Because,
Any
for
number-
example, or the plus cuts that I showed you earlier.
Any number, when you restate that conjecture?
So any number that is 1 greater than a multiple of 3.
But 8 can be.
Okay, any
So,
more?
for
What's it
example,
up?
that surely should be cuttable. So we can't like rule out those since we can do those.
Okay. So which ones can we do? We can do the ones that are one more than
A
the multiples of
3.
3. What's another way to state that? What's another way to say the same thing in different language? I like that. And what's another way to say it? That some people might be more familiar with.
3x plus 1.
Yeah. A number X.
Yeah, but that one is what? Also, another way, if we use some other language, divisibility language.
If something divided by 3 that has a remainder of 1.
Yeah, great. That might be, see? So if when you divide it by 3, you get a remainder of 1.
One.
You guys are saying exactly the same thing.
Yes.
You see? Exactly the same thing. Good,
Yeah.
good. So the conclusion, so we have a conjecture. Our claim is that if when you divide the number by 3,
Yes. And it gives a remainder of 1, then it has to be then it has to be cuttable into. It has to be the number of squares that we can cut into.
starting out of what?
One big square.
So you start out with one big square, and can you show us how you would follow this pattern? Let's see if we're all following.
So we start off with. Should I erase all the stuff on the board?
If you don't like it, if you want to erase it, feel free.
Okay, I'll erase my own. I agree. I'm not gonna erase these. Okay. So we start off with one big square. Next, we do a segment. We get 4 squares. 4 divided by 3 gives a remainder of 1. Okay, let's do a different color. Let's do a different color. 7. 7 divided by 3 gives a remainder of 1, and 6 is one more.
Okay.
Next. That means we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 10 divided by 3 gives us one number. Next, we try. Well, let's continue going.
So 4 took you to 7, and 7 took you to
10.
To
And
10.
And then we can continue doing this. 13.
Okay, so I agree that we might need to clean the board a little. So let's see, anyway. You're saying that so far, 4 took him to 7, and 7 took him to 10, and 10 to 13, and so on. Do we agree?
Plus 3.
Yeah, it's just plus.
Okay. So we can get, and those are the ones that when we divide by 3, give us a remainder of 1. Okay.
It's a type of sequence by squares.
Is that all we can do?
No.
Oh, no?
You can do anything.
What? Oh, we are, okay. So, this is not, we're not saying that, say it again?
They are not the only one we can do.
Yes.
It's assured that they are possible.
So multiple ones can be doing it, but we have confirmed that these have to be.
So we have a way to generate these.
Yes.
We have a way to generate these that looks clear. So we still have a few questions to. So what about? Suppose we're doing the chart that we said we were going to do, and we have, say this is the number of squares, the number of squares that we want to cut it into, on whether we can do it or not. I'm going to use a check mark for a yes and an X for a no. So what about 1? Can we cut it into 1 square?
Yeah.
Yes.
Just
No.
start.
Here I see yes.
You can't cut it in.
You can't
Yeah.
cut it.
Start off.
But just turn the whole side off.
But you can take the whole thing and it'll be, so 1, we usually say in mathematics that that's the trivial case.
Yes.
We don't have to do anything to it, it comes with it, yeah, it works. So this is the trivial case, good, it works. Now, let's see what we have so far. I'm gonna go to what we have, 2, 3, 4, 5, 6, 7, 8, 9, 10, say 11, 12. Let's just, so already we have that 4, 7, 10,
10, 11, and
11,
1.
and
I'm going to use another color now. So because I'm keeping these in pink because we saw that these came with this one, right? So let me just put this in, like 4 gave us 7, 7 gave us 10, 10 gave us 13, and so on.
It's +3 because like you make it into 4 squares and the whole square is -1.
That's already 1
So
So
third.
it's
you start with
4
1.
minus 1 is 3.
Should we start with
1.
maybe? I don't know. We want to start with 1? Where does 1 take us?
1, if you add 3, you can get 4. When you add 3, you get 7. Just add a 1 at the beginning.
Oh, he says if we can do, this is the same as starting out with 1.
Yes.
1 when it's divided by 3 gives us a remainder of 1. Very good. So Varun is saying, I like that Varun. Varun is saying this guy should be part of this whole set
Yeah.
of answers. Okay, I agree.
I got one with 12.
You got 12.
Yeah, I
Okay.
got 6.
You got 6. You got 12. Let's see 12 and then let's see. Let's see 12 and let's see 6. What do we have?
Basically, I started off with a square. I'll start off with any square, and then I did 3 vertical cuts of 6.
So can we, how can you refer to this that might be simpler? How can we refer to this square that you have now? If you look at it as a,
So I started off with 9 squares,
so we
and
select
then I did 9 by 3 because and I got 3, so that's 3. And then I cut up this square into 4. So and then I got 12. So then 12 divided by 3 is 4. So I got 4 as a remainder. And then I cut up that square into 4 as well. And I got 15, and then 15 divided by 3 is 5. So my pattern is 3, 4, 5.
wait, how can you do 5? Oh, I don't see 5.
Like 1, 2, 3, 4.
She claims to have 5.
No.
No, not 5, but
No
like
5?
but like my remainder is 5.
Your remainder divided by what?
So 15 divided by 3 because I have 15. I made
Wait,
15.
but if you divide 15 by 3, you have no remainder.
Oh, no, like 15 divided by 3 is 5.
Yes.
So, and then 12 divided, and then 9 divided by 3 is 3. And then 12 divided by,
So you are dividing by 3 and then dividing by 3 again with
Plus
the goal
3
of
divided by
getting
3.
what? With the goal
Well,
of,
I don't know, but like,
let's see if we can, let's see, let's talk to each other. Let's see about what we can fill in from that chart. We already have 1, 4, 7, 10, and so on. Let's see if we can do something similar that will help us with the other cases, or maybe not.
Oh, perfect.
Whoa! So we already have ideas?
Yeah.
You guys think too fast. Okay, wait a minute. Let's go. What do you have?
We can do any number between 6, 12. It can be 6 plus 6, any number that has 6 repeating in it. Like 6, 12, 18.
we can do 9
What do you
too.
mean by
We can
6
do
repeating?
9.
I know, I'm just crossing out the
But
number.
what was the technique they used here? What was the technique here? What was the technique here?
Divide by 3.
Divide.
Oh, by 3 remainder 1.
No. But what I mean is, we started out with, look, 4 took us to 7. How did it take, why and how did it take us to 7 from 4?
We added,
Because we added.
We cut it into
added
4
4
and then
squares,
it's
but then no, in total we just removed 1 square, so that would result in 3. So for example, if we were
minus
to
one.
take this using 9 squares at first, then we would, when we do the next code, we would have 8 squares, which means we could form a different pattern. If we were to divide into 16 squares, then we can have 15 squares.
So what do you want to start out with then?
So next we could start off with 1, then 9, then 17, and so on.
Wait, 1 and what?
Then 9 by adding 8. We can like do another.
Well, yeah, but can we make it? We could. I agree that we could.
Yeah, but we might be able to. We could start with 6.
We could start with
I
6.
found a way to make 6.
Let's see. Go ahead, share. Yeah, you were gonna share with us 6.
Yeah.
We could,
Let's do 6. Let's do 6. You can. Yeah, go ahead. And why don't we use this blue so we can? Go ahead. You can use whatever color you like.
Now we just do 2.
Wait, do it again.
Yeah, we have to do 2.
We cancel this.
So you can cut it. We here. You know, work. Talk to your friends. What do we have here? Well,
I know it's impossible to get 2 and 3 because to get a square
3 you can
into
get 3. No,
you can't. To make a square into more squares, you need minimum 2 cuts to make 4 squares.
Yeah, you need minimum.
I like this. We will as soon as Baron finishes. We want to go in that direction. I like that. I like that. We have. There's a great idea there. Let's look at Baron. Wait. What is? Oh yes.
Is it a 3 by 3 square?
So Baron is starting with a 3 by 3 square. Go ahead.
This is 1, this is 1, and this is 1, and this is 1.
Yes.
This has to be 2, and this has to be 2. This is 1, this is 1, this is 1, this is 1. And the areas add up to 9.
Yes. So the sides, very good. So we have. These are all unit squares,
Yeah.
and this one is a
2 by
2 by 2. So we have.
6.
We have 6. So we've done. We can put a check mark here. Let's do it with another color so that we don't.
I haven't.
We can do 8.
So we can do 6. Wait. But let's take 6. Let's take 6. Oh, you see, he's fast. He took 6. 6 took us
8 or 9.
to 9
Then
and to 12 and so on.
Plus 3, plus 3.
Applying the same, starting with a different one, but applying the same technique that we use. So can we put it below here in blue, and maybe 6?
Yeah.
So we can't use 2 or 3.
Okay, we want to look at 2 and 3. We want to look at 2 and 3. I hear some reservations about it. Some of you don't like 2 and 3 for some reason.
How far are we going from the original count?
It's good. It's good. We're going. It's good.
7.
I got 8 too.
You got
I can do it.
Oh yeah, yes.
an 8 will give us something else.
Yeah, 8 is like that 11 one, but instead take away the plus one.
Yeah.
So
8 is the same thing.
Yeah.
Except take away the
And then you start with 8, and then you add that to get 11, and then you add that to get.
so why don't we go to the board? Let's start with 8. Let's go with 8. Let's go with 8. Let's do 8. Let's do 8.
So
You guys, you are. I'm impressed with how fast you guys are
if
doing.
you take this away, then you'll get 8, and then if you add that back in, you'll get 11. And then if you add that right here, you'll get 14. And then if you keep adding that, it's
Okay,
still
so you
plus
want to
3.
start out with how many? Oh,
So if you take this away,
okay.
you'll get 8 squares.
Okay, so let's erase that whole. I got it. So, do you see it? We have 8. So he started out with 8.
Yeah, and then once you add this, it's 11. And then if you add this, it's 14, and then it's just...
So let's mark it with another color. So that's, let's use purple. There we go, purple. So we got 8, and then that gives us another sequence. Why don't we write it below the blue one? Why don't we write it below the blue one?
Okay.
Below the blue one. So, yeah, that one is kind of dying, that purple one.
I think it would be better if you were to write it above the blue number so that a pattern could be more noticed. Below 7, but above 9. Just start writing the 8 and write the pattern there.
No, but then it goes
4,
in
6,
sequence.
8 is where it
It's
starts.
good, yeah. It's 4, 16, or 4, 6, 8.
No,
But-
what
then the next
what I'm
one's
just
gonna be
saying is,
10.
in order for us to understand that all numbers that are above 6 can be used squares, just start the
No,
pattern.
but then
No,
these...
that's where it starts.
No, what I'm
This
saying
is a sequence of 2 from the start
It's a question. Wait. It's a question of organization. It's okay. I see it. Who was it who said that? I think it was Hardy. Did you watch the movie The Man Who Knew Infinity? There's a
But
famous
it's
quote
not 16, it's 17.
by
Oh, yeah.
It's
what is it?
Yeah.
Hardy said there is no place in the world for ugly mathematics. So we want to express great mathematical ideas in a beautiful way. So I like this, wanting to organize it in a way that it does justice to how pretty the idea
still
is.
organized.
Oh,
Yeah, it is
See,
organized.
If you look at the columns, all of them are +2, +2.
Yeah.
Yeah, it's
So
going in
basically every
numerical
single
order.
number that is greater than 6 can be covered up to infinity.
Okay, so now.
Oh wait, now if you keep going, like 10,
keep going.
10, 13.
Yeah, it would
Yeah.
be any number greater than 4.
Now we have to
At
just
this
find
point,
five between
if
two.
you can divide it into a starting number 4, 6, 8, 12,
So
14, 16.
so far we have a way from 6 forward
Yeah,
uninterruptedly, from 6 on,
yeah.
we have a way.
No, from 4 on.
No, but from
No, no.
Oh,
Uninter-
never mind.
so far we don't have, maybe we can find 5, but so far, what happened to 10 here? 10 was,
But 10
That
is
was
part
pink,
of-
10 is
that's
pink, it's pink, oh, they're all there. So far uninterruptedly, we have from 6 on, and we know that we will hit eventually every single natural number
Pass.
past 5, because now we have 3 issues. We have to deal with 2, 3, and 5.
And then 2 and 3 can't be made because, like I
Yeah.
said before.
Okay, let's see why 2, okay, let's hear that. Why can we not make 2 and 3? Let's see if we can hear a convincing argument, and then,
Well, it can't be 2 because even if you do one cut, you're gonna get 2, but it's gonna be rectangles.
so when you do the first cut,
And then if you do multiple cuts, then you're gonna get a greater number. So, and it has to be 2 squares.
Yeah, it can only be 1 cut to
Yes.
get 2 squares.
Yeah, with the
Yeah,
starting
you can't
of
do
a
that.
square, to make another
To make
square,
2
you need
pieces,
a
you need
minimum.
one.
Yeah, you need a
Yeah.
minimum of 4. Yeah, cuts.
To
Yeah.
make 2 pieces out of 1 piece, you need
No,
1
2
cut.
cuts.
you need 1 cut, okay,
Yeah.
simple idea, I like this. If you're going to make, so you have 1 whole piece, 1 square, to make 2, you need to use,
1.
and as soon as you make that 1 cut, because suppose you don't do it all the way across, well, if you don't do it all the way across, it doesn't,
Not really.
yeah, so, okay, so,
You
so
like-
2, what about 3?
Yeah, and that also rules out 3.
Because plus cut makes 4.
Yeah.
Yeah, I
So
would.
if you make
Oh, that's why you call it plus cut. Now you were saying, some of you were saying plus cut, and I'm like, well, I get what the plus cut. Now we have a terminology that is being
It turned
developed.
2 cuts.
Yeah, a plus cut. I get it now. Okay,
The
yes.
same thing with 2 goes on to 5.
Yeah.
Oh wait, why does it apply to 5?
It's because when you cut, so you could do 2 by 2, then you would get 4. Wait, no, sorry. You could do 2 and then 2, and then you would have one left over that would be 4. But if you cut, it'll become rectangle. It's a
Well, I think you have the right idea, but I'm not following quite I'm not saying you're wrong. I'm saying that at this point I'm not able to follow your reasoning. May you please say it again?
Yeah. So to make the 5, you would you would make a square, and so since you can't do 3 and 3 because that would equal 6, so you do 2 and 2.
2 and 2 meaning, what do you mean 2 and 2?
Like so, 2. And
You start out, what are you starting out with?
1 square.
1 square.
1 square. And then you would make 3 parts,
Okay.
and then you would have a 4th.
Yes.
But if you cut that in half, it'll become a rectangle, and you cannot make and then if you added 1 more, it would become 6, and you do 1 extra.
I see where you're going. Let's see if we can refine that.
Like going off of what he said, so you can't do it has to be a full cut. So let's say you start off with 1 square, and then you do 2 cuts, you have 4. But you can't do a cut halfway across. Like it has to be a full cut. So let's say we divided this into 2, then it would be 2 rectangles, so we would have to do another cut, and we would end up with 1, 2, 3, 4, 5, 6, 7. So you
can't really
Can't do.
Yeah, you
You
cannot.
can't.
You cannot.
We can't.
You can? You say we can't?
Can't.
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 Okay, now, how many, let's see, how many corners are there in a square? We're gonna wrap this up, we're gonna start wrapping this up. So we have 4 corners in a square.
Yes.
Yeah.
And when we cut, so every corner on our square, so we have a square, just to look, every corner on that square, when we cut it, must be part of what?
Another square.
It must be part of another square. Can we use that idea?
Yes.
Every corner, when we cut the square, every corner of that square must continue to be the corner of some other square.
Yes.
Of some other square, right? Okay. So can we make 5?
No.
We have to find out. We have to just like continue finding the number of squares that have the corners there, and if we can somehow deduce that it's if we can 1, 2.
Then we still can't.
Okay. So there is the seed of the right idea is there. I want to summarize the lesson, and I want you to think about it. I want you that'll be your. I want you to think about this. What have we? So let's look at our question. Can we rephrase our question, and can we make it into a conjecture, and then answer that conjecture, and make it into a theory? Okay. So let's see. What is our question? Let's make it into a conjecture, and then let's see. We've already given we have the elements of the proof of our conjecture.
What do you mean by
A conjecture is what we say, what we claim to be true. We claim this is true, and then we show you, we prove to you that it is.
on a number line, it would be.
Yeah, you can make infinite squares.
You can draw a ray
Because
on the
it's a
number line.
never-ending sequence, even if it starts at negative infinity or a number, a certain number, it goes on.
So how can we say that very, very beautiful?
As I said before, like it can even be a microscopic square.
Yeah.
It's gonna go on and on and on.
You can't really think of it physically, but like.
Yeah, but in terms of our original question, into how many squares can we cut a square, how can we turn that question now into a claim that we make?
Yes.
Let's see.
So if a number is greater than or equal to 6, then we can cut it into a certain amount of squares. But if the number is less than 6, then it has to be you're correct. It has to be a perfect square.
Okay. I like it.
On a number line, you could make it like.
On the number line, 6 from 6. So how can we? Sometimes mathematicians, they look at this as, they say, for every, what are those numbers? What do we call those numbers? 1, 2, 3, 4. What do we call them?
Consecutive numbers.
Counting
numbers.
We call them the counting numbers. Mathematicians usually call them
Natural.
the natural numbers. Usually, you can call them whole numbers, counting numbers. It's okay.
Integers?
But integers would include
Zero.
negative. But natural numbers. Natural numbers. Yeah. That's the preferred word. So we call them. So for every natural number, so we say that we can cut a square into any number of squares n, where n is a natural number, except for
1, 2, 3, and 5.
2, 3, and 5. So we can cut a square into any number of squares for any natural number except 2, 3, and 5. So my question now would be, okay, so how can you cut a square into 2019 squares?
So we have to divide it by 3 first and see what remainder that gives.
And that would set it into one of these categories.
That would not be remaining.
Yeah, there would be
Not
no
be
remainder.
remaining.
No. We have to divide it and find out the remainder. If it has a remainder of 1, we go to
But if you divide it by 3, it's not remaining.
So I like that idea. What is that again? So he's looking at the remainder.
It might be
He's
remaining.
looking at the
It would
remainder.
be 6, 9, 12, 15.
There is no remainder, but then the middle category has no remainder.
Well, remainder 0. Remainder
So
0.
we'll go into the middle category.
So if we look at them from down here, look, down here. down here. So look at the remainder now. Look at the remainders.
Is divisible.
What are the remainders of the 1 in 6? What are the remainders now? What are the remainders?
0.
0, remainder 0, remainder 1, remainder 2.
Remainder 0.
So when we're looking at these three, we can look at 6, 7, 8. We can look at 6, 7, and 8 as our starting points.
Yeah.
And then if the remainder is 0, it lives here. If the remainder is 1,
Yeah.
it lives there
So-
in that
so
set.
it's remainder 0.
So
So
you don't have to divide it or any remainder, it'll just be part of one of these sequences.
It is part of them,
It is.
but the point is, if I give you a number, how do you know in which one it lives?
Yes.
Oh,
you
yeah,
you
you
need to divide
divide
by
by
remainder.
Divide by
If it has a
three.
remainder 1, it goes into the red category. If it has a remainder 0, it goes into the blue one. And if it has a remainder of 2, it goes into the purple one.
Yeah.
Perfect. So we'll stop here. Although I want to do an extension. I want to do an extension with